Hello class, welcome to this video lesson made by yours truly, Teacher Lay. And again, I would like to greet everyone Happy Hearts Day. And for today's video, I will be discussing the biconditional, inverse, converse, and contrapositive statements. Let's do this. Our objective determines the inverse, converse, and contrapositive of an if-then statement. You have learned that conditional statements are true if the hypothesis and conclusion are both true. And with that, we'll be asking this question: if we interchange the conclusion and the hypothesis, will the resulting conditional statement be true? Later on, we'll be able to answer this question. And as an introduction, in this lesson, you will be able to make a converse statement from the given conditional statement. Additional, the same way an inverse and contrapositive statement can be derived from the conditional statement. So are you excited? Yes, let's be excited together. So, as a reminder, you must be done in answering the pre-assessment posted in our Google Classroom. If you're not yet done, you may pause this video and then answer it first. If you're done, keep on watching and learn from this video. Now to start with, you have to do the learning task 1 from the self-learning module in Mathematics 8 on page 23. 2A, determine if the given conditional statement is true. Letter B, switch the hypothesis and the conclusion and determine if the resulting statement is also true. And lastly, letter C, you have to write the hypothesis and the conclusion in negative form. So don't worry, I'll give example for this learning task. Let's have this example. If the figure is a quadrilateral, then it has 4 sides. Okay, so the first task is to determine if this is true. Now, in geometry, the definition of quadrilateral, it can be defined as a closed, two-dimensional shape which has 4 straight sides or simply has 4 sides. So therefore, the given conditional statement is true. Yes. Okay, next, letter B. What we're going to do is switch the hypothesis and the conclusion. Just interchange their position. So therefore, from this, the yellow and the blue, hypothesis and conclusion, respectively, will just change their position. It will be this statement. Okay, if the figure has 4 sides, then it is a quadrilateral. And again, we can say that this is true. Okay, let's proceed with letter C. Switching or interchanging the hypothesis and conclusion gives us the converse statement. So, this is it. We have now the converse statement. When we talk about converse, switch or interchange the hypothesis and conclusion, their position. That is converse statement. Now, let's proceed. Letter C, write the hypothesis and the conclusion in negative form. With this, we just need to negate, meaning just add not or no, it depends. Just negate the statement. So, if the figure is not a quadrilateral, then it has no 4 sides. This is the negative form. Okay? And what is this? What do we call this statement if we negate? We call this inverse statement. Okay? I'll read this again. Negating the hypothesis and the conclusion gives us the inverse statement. Of course, when we switch or interchange the hypothesis and the conclusion of the inverse statement, now the result is what we call contrapositive statement. If the figure has no 4 sides, then it is not a quadrilateral. Okay, and that is contrapositive statement. In simple words, we can say that contrapositive statement is the converse of the inverse statement. Okay, got that? Okay, so always remember that contrapositive statement is the converse of the inverse statement. Okay, so let's wrap up the 3. From the conditional statement, we can come up with a converse, inverse, and contrapositive. Let's start with the converse. When you switch the hypothesis, this is just a recall, and conclusion of a conditional statement, you form a converse statement. Here is an example of converse statement. Given the conditional statement, if a man is honest, he does not steal. If a man does not steal, he is honest, as its converse. Now, we can say that the conditional statement is true, and of course, the converse is also true. If a man does not steal, he is honest. And remember from last week, from previous week, I've said in my previous video that conditional statement does not always appear in the if and then form. Sometimes if and then can be omitted. So like this one. Another example of converse statement. If the triangle is equilateral, then it is equiangular. Given the definition that an equiangular triangle is always equilateral triangle, with this we can say that this conditional statement is true. And another definition, which is an equilateral triangle is always equiangular, then the converse statement, which is if the triangle is equiangular, then it is equilateral, is also true. Okay, I'll move my face. Let's proceed with this. Always remember that since both conditional and converse statements are true, you can connect the phrases by if and only if, or IFF. Thus, it forms a biconditional statement. Here it is. What is biconditional statement? A triangle is equilateral if and only if it is equiangular. So the words if and only if implies that both conditional and converse statements are true, and that is biconditional statements. Okay? If both converse and conditional statements are true, we call that biconditional statements. And we can use the if and only if to these statements. Okay? Now, let's have some example of biconditional statements. Two angles are complementary if and only if the sum of their measures is 90 degrees. Now, for its conditional statement, if two angles are complementary, then the sum of their measures is 90 degrees. And its converse, by the way, this conditional statement is true, of course. And its converse, if the sum of the measures of two angles is 90 degrees, then they are complementary. Okay, this is also true. Now let's remember from converse, let's have now the inverse statement. An inverse statement can be formed by negating the hypothesis and the conclusion of the conditional statement. And the contrapositive statement when you negate the converse statement. So therefore, let's proceed to the application. Application of the converse, inverse, and contrapositive in geometry. Let's have this. If two angles are congruent, then they have the same measure. What will be its converse? You may try to answer, right? Okay, I'll give you time to answer. Okay, here it is. If two angles have the same measure, then they are congruent. How about its inverse? Let's see if you're correct. If two angles are not congruent, then they do not have the same measure. And lastly, contrapositive. I know for sure you have your answer in your mind right now. So if two angles do not have the same measure, then they are not congruent. Okay? Take note. In the above example, since the hypothesis and conclusion are equivalent, all four statements are true. From conditional, converse, inverse, to contrapositive, they are all true this time. But this will not always be the case. Let's look for the next example. Again, application to geometry. If a quadrilateral is a rectangle, then it has two pairs of parallel sides. What will be its converse? If a quadrilateral has two pairs of parallel sides, then it is a rectangle. And it is false. Why false? It doesn't mean that the two that a quadrilateral has two pairs of parallel sides, it is always a rectangle. No, it can be a square. Okay? What else? Two pairs of parallel sides. Parallelogram. Okay? See? So, it doesn't mean that a quadrilateral with two pairs of parallel sides, it is meant for a rectangle. No. So, it is false. How about the inverse? If a quadrilateral is not a rectangle, then it does not have two pairs of parallel sides. Again, parallelogram. A parallelogram has two pairs of two parallel sides. Okay? So, contrapositive, of course, this is true because it is equivalent to the conditional. So, if a quadrilateral does not have two pairs of parallel sides, then it is not a rectangle. Okay, look at this. I will be discussing in my next video about the truth tables, wherein you will learn about the some interesting facts with these logical arguments, whether it is true, false, true, false, true, false. If the converse is true, what will happen to the inverse? If the conditional is true, what will happen to the contrapositive? Which of them are logically equivalent? Okay, you will learn that in my next video next week. Let's proceed. How about let us apply this to careers? Like, for example, lawyers. Lawyers represent people in criminal and civil trials by presenting evidence supporting their client's case. Now, here is the conditional statement about lawyers. If you're a lawyer, then you give advice to legal matters. And it's conversed. If you give advice to legal matters, then you are a lawyer. And in its inverse, if you are not a lawyer, then you do not give advice to legal matters. And for the contrapositive, if you do not give advice to legal matters, then you are not a lawyer. Okay? So we can apply this conditional, converse, inverse, contrapositive in different areas. You can apply it in your English topic, in MAPE, in science, right? In even in Tagalog, you can write it. Okay, let's apply it to another career. Okay, here's another career: architect. Okay, architecture. Architects design buildings that are functional, attractive, safe, and economical. So here is the conditional. If you are an architect, then you plan, design, and oversee the construction of buildings. And it's converse. If you plan, design, and oversee the construction of buildings, then you are an architect. And for the inverse, if you're not an architect, then you do not plan, design, and oversee the construction of buildings. And contrapositive, if you do not plan, design, and oversee the construction of buildings, then you are not an architect. Lastly, another career, chef. Chefs prepare meals that appeal to both the taste buds and the eye. They often direct kitchen workers, estimate food requirements, and order new supplies. And here's our conditional statement. If you are a chef, then you prepare meals that appeal to both the taste buds and the eye. If you prepare meals that appeal to both the taste buds and the eye, then you are a chef. Inverse. If you are not a chef, then you do not prepare meals that appeal to both the taste buds and the eye. And it's contrapositive. If you do not prepare meals that appeal to both the taste buds and the eye, then you are not a chef. So I'll give a challenge to you. What are you going to do is to provide your own statement that you will write its converse, inverse, and contrapositive. Okay? So let's wait for the instruction. Of course, I will upload it also in our Google Classroom. Now, I think this is my last slide for the topic. I'll just give you some reminders. So do the learning task 2 and 3 for this week, also the supplementary activity for week 6 and 7 uploaded in the Google Classroom. And on Friday, don't forget to answer, of course, the post-assessment and the exit ticket to be uploaded in the Google Classroom as well. I think that will be also goodbye class. And thank you very much for listening. I hope you learned something from this video. Thank you.